Hello and welcome to T1 Day 24 of Honors Precalculus. We're going to graph secant and cosecant functions today, but we're going to first start out by graphing some sine and cosine functions to warm up. So we're dealing with cosine here, and now we have a midline at -2 because of that -2. So our midline is going to be right here at y equals -2, and our amplitude is going to be 4. That negative is going to flip it over. So usually cosine starts at 1. When x is 0, it's at 1, but it's going to flip it over and go 4 down from the midline. 4 down from the midline will therefore put it at -6. So it starts here at -6, and then it comes back at 2 pi and back at 4 pi. And if you go up 4 from -2, you end up here at 2. And then you just keep it going to the left, draw in all of the equilibrium points where it crosses the midline, and then use a highlighter. I like using the highlighter. It makes the curves a lot nicer. At least I think so. You can also copy and paste the same curve over and over again if you want to, but that's all you need to do. Now on the second one, we're going to move it up to 2. So the midline in this case is going to be 2. So we'll put our midline here at y equals 2. And the amplitude is going to be 3. But this minus pi over 2 right here is going to move it, instead of starting at 0, sine of 0 is 0, it's going to start at pi over 2 and go up 2. So it goes over pi over 2 here and then up 2 to here. So that's where it's going to start, kind of that middle point, and then it's going to repeat every 2 pi. So not at 2 pi, it's going to repeat every 2 pi. So here and then at 3 pi, 2 pi, so it's going to be a little bit off there. So we'll go back 2 pi to here. Remember the general shape for sine is it's going to go up first, and then it goes, and the amplitude of this is 3, so it's going to go up to 5 here, and then it'll go down to, come back down to here, sorry, being a little pain, and then it goes down to the -1 right here, it's 3 down. So this is the cycle in sine that gets repeated. So it goes up, down, up. And again, the midline is 2 because of the +2 right there. And this is the shape that repeats itself every 2 pi. So you could highlight this and copy it over and over again. I made a copy of it right here. So then you can then take this and move it over here and just place it right there. And then I'm going to make another one. Just go like this. You go paste. And I'll put that one right here. There it is. Just repeats itself over and over again. It's pretty cool. So now we're going to graph cosecant. And remember that cosecant of theta is equal to 1 over sine of theta. So let's graph sine. Sine starts here at 0. It goes up, down, down, and then back up again. And you end up with this curve right like this. That curve gets repeated. And that right there is sine. Remember, cosecant is 1 over sine. So what you can do at each of these is try to do one at a time point plotting to see what happens. So let's talk about where interesting things happen with cosecant. When sine is 0, it's undefined. So when is sine 0? Sine of 0 is at every multiple of pi. So at every multiple of pi, there's going to be a vertical asymptote here. There's going to be a vertical asymptote every pi, because every multiple of pi, sine of that is 0. So there are vertical asymptotes repeating. And then, when sine of theta is 1, 1 over 1 is 1. So cosecant, whenever it's 1, will still be 1. And also at -1, it'll be -1 because 1 over -1 is -1. So you know these are blue points that are on cosecant. So what happens here, if we zoom in here and take a look at what's going on, if we look at what's going on from, let's say, here to here, as x gets smaller, you have 1 over a smaller and smaller positive number. 1 over a smaller and smaller positive number means it's going to go up, and it's going to go up over here. And then the same thing is going to happen on the other side, but instead it's going to be negative, so it's going to go down, and then up, and up, and down, and down. So cosecant graph looks like this, and my curves could be a little better, but it's the same thing. It's the same periodic function. It repeats itself, but there are a whole lot of vertical asymptotes. So the graph of secant is very similar because what you do is you graph 1 over cosine because 1 over cosine of theta is secant theta. So cosine starts at 1 and it repeats itself, goes down to, it comes back every 2 pi. So it comes back every 2 pi. So it goes down here, so here, 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 and here. And then we can take this, and here is our cosine. So I'll do the same thing to the left. And there's our cosine graph. So this is going to be the secant with their, secant is going to be undefined when cosine is 0. So cosine is 0 here, pi over 2 at these. So this is where the vertical asymptotes are going to be. You're going to vertical asymptotes here, 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 here. And it keeps on repeating, periodic once again. And then the same thing is going to happen where secant, it's going to be when it's 1, it intersects at 1, so 1 over 1 is 1, and 1 over negative 1 is negative 1. And then the same thing happens where you get these upward parabola-esque things. They're not parabolas, but they curve like them. So you end up with this right here. Yay, very cool. Very, very cool. So you don't have to graph cosine to graph this, but it helps to see it. So the system for transforming these is exactly the same as it was before with sine and cosine. This 2 means it's going to have a midline at 2. So there'll be a midline here. And then what did this do? Well, this 3 right here is going to stretch everything vertically by 3. So instead of going up 1, it's going to go up 3. So remember, it would have normally started 1 up from it right here, but cosecant is therefore going to start up here at 5 because 2 plus 3 is 5. So it's going to start here, and then every 2 pi from there, it's going to repeat. It's going to repeat. And then you know there's vertical asymptotes every pi, like this. Every pi. 2 pi, and then 3 pi. And then once you get those, you kind of fill in the blanks. You can write in some more vertical asymptote and plot more of these points so you know it's going to be there, there, back again, and then back again. And then down at the bottom, it's going to go down to, it's going to go 3 down from the midline, 3 down from the midline, so negative 1. So it's going to be here, and here, and here, and here. A lot of things repeat themselves. And the shape goes up from these things. It goes up from these, goes up, and goes up, and then it goes down, and down, and down. That's a terrible curve. I got to do better than that. Down, 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 and down. And the reason for that distance is because of this 3. Because of that 3 right here, the distance here has to be 3. So the midline was 2, so you had to go up 3. So on the second question, I'll leave this to you to practice. You would do the same thing, but you're going to go, the midline will be down at negative 1, the midline will be down at negative 1, and then it starts 4 above and below, and it reflects. So that's an amplitude of 4. So your amplitude is 4, and there's a reflection, so it's just flipped down, and the midline is y equals negative 1. So in this case, our midline is going to go up 3, and this is secant now. Remember, this is secant. So it's going to go up 3, so our midline will be at 3. So here it is. Here's our midline, y equals 3. And normally the secant shape used would start at 1, but now it's going to be a stretched 2, and it's going to be 3 above where it started because the midline is now at 3. So it's going to be 2 above the midline. So instead of starting at, usually secant would start here at 1, but then you're going to move it up to 3, but then you got to go a distance of 2 from that because of the stretching here. So it's actually going to be at 5, but then it's going to be 2 to the right, pi over 2 to the right, pi over 2 to the right. So instead of starting here, it's going to be 3 above and pi over 2. It's going to be there. And what's going to happen, therefore, is that every 2 pi, it's going to repeat. So every 2 pi, so then it's going to be here, and then it'll be at negative 3 pi over 2 right there, and then it'll be back again at negative right here. Yay. Okay. So then the opposite, the other points are going to be 2 below the midline in between. So 2 below the midline in between is going to be at 1. And then you know that there is going to be vertical asymptotes whenever the denominator is undefined. So remember secant, so secant of theta minus pi over 2 is equal to 1 over cosine of theta minus pi over 2. So it's going to be undefined when that's 0. It's 0 when cosine is pi over 2. So what do you have to plug into this? Cosine of theta minus pi over 2 is equal to 0 when theta is equal to pi. So that means there's going to be a vertical asymptote here, here, and here, there, and there, and there. And that matches because this needs to go up and that needs to go down. So all you do is repeat that. And here's what you get. It's going to be, technically these are twice as steep too. You stretch them up. Now there's a second question here. Same idea here. It's a reflection. That's a reflect. And our amplitude is now 3. And you move left pi and up 2. I'll leave it to you to practice that.